Hi everyone, in the last video I have shown how to create animations of motions with constant velocity and with constant acceleration, but I have not included situations in which the motion has turning points. Today I'm going to include this situation, and I'm going to show you how to tell Maxima to change the dimensions of the animation according with the change in the initial parameters of the motion. Before we start, if you think videos talking about free software should reach more people, please help us by clicking the like button, letting a comment, and subscribing to the channel. So let's start. So let's start defining the initial parameters of the motion. This is the initial position, this is the initial velocity, and this is the acceleration. Then we are going to define the function that's going to return the position of the particle there. We are going to define the velocity from the position. So if we change the function that is going to return the position, then the velocity is going to change accordingly. Let's determine the position, the time when the particle gets in the turning point. Then we are going to use solve, and we want to define a variable to get this value. So we are going to define tr, that's going to be the right hand side of the first element of the last output. So remember that this percent sign refers to the last output. And the last output is a list, so we have to tell Maxima what element of the list we want. And since this element is inequality, we have to get the right hand side, so that's why we use RHS. Then let's see where the turn point is. Then we're going to define a variable to get this value. And let's determine the maximum time of the animation. The minimum value in the horizontal axis is going to be the turning point, and the maximum value is going to be the position when the time is maximum. There. So before we generate the animation, let's generate a graph of this motion to see if everything is okay. So I'm going to make this there. So the graph shows that these equations are okay. Now let's generate the animation. So I'm going to define the number of frames. File name, let's set this is a motion with constant acceleration, so I'm going to put this. Let's set the terminal to animate that GIF. And we have to use make list and gr2d. Let's already put some options. First, x range. So we already have defined these values. Let's also put here point type and point size there, and points to draw the particle. This is a horizontal motion, so the second entry here is going to be 0. And now we have to tell make list the interval of the time that's going from 0 until Tmax, and the step that's going to be this there. Let's hope everything is okay, and there. So our animation has been generated. So let's see in the folder where the code is. Here it is, and our animation looks like this. I would like to make some things to improve this. So the first thing I'm going to do is to add here an option that's going to change the dimension of the graph so that the horizontal the size in the horizontal direction is going to be larger than in the vertical direction. So sorry, dimensions here, there, and let's update here to see how it looks now. There, so it looks like this. It's not interesting to show the ticks in the vertical axis since this motion is only in the horizontal direction. So I'm going to put this option here, there, and now our animation looks like this. I would like also to insert the velocity vector there, so I'm going to make this. Let's put this vector in green color. I'm going also to change the head length of the vectors, and then vector. The first list in vector is going to set the initial position of the vector, and then the second list is going to tell the vector what are the components of the vector. So let's see how our animation looks like. Sorry, it's green here, there. Let's update here. So our animation looks like this. We see that the velocity vector is too big to be shown in this animation. So I'm going to reduce its size. So I'm going to divide here the components by 5, there. And now my animation looks like this. The animation is still not perfect, since the vector disappears here near the returning point and also near the maximum value of the position here. So what I can make is to change the minimum value of x and the maximum value of x. So here I'm going to put -1, and here I'm going to put +1, there. So let's see how the animation is now, there. So the animation looks like this. So now the vector appears in all frames of the animation. I would like also to insert the acceleration vector here. So this is going to be very similar to what we did to the velocity vector. So I'm going to put it in the color red. The starting point of the vector is going to be the position of the particle, and these are the components of the vector. And I'm going to divide it also by 5 so that it does not appear too big or too small, there. So let's update here, and now our animation looks like this. And you can see that the acceleration vector remains constant while the velocity vector is changing constantly. So suppose now we would like to change here the initial velocity to a positive value and the acceleration to a negative value. So we are going to have a problem now because the minimum value of x is going to be larger than the maximum value. So when we try to generate the animation, Maxima complains about this. So how can we solve this so that we can have one code only to both the situations? The first situation when the initial velocity is negative and the acceleration is positive, and the second case when the initial velocity is positive and the acceleration is negative. So we can tell here to Maxima what is the minimum value between the turning position and the position when the time is maximum. And here we can tell Maxima what is the maximum value between the turning position and the position when the time is maximum. So we are going to use these options. This that determines the minimum value between these numbers, and this that's going to return the maximum value between these numbers. And I'm going also to reduce this by 1 and increase this by 1 there. So now we can see that the minimum value is smaller than the maximum value. Now let's try to generate our animation again. So no complaints now. And let's update here. So now we have a inverse situation that and our animation has adapted to these new values. So this is interesting if you want a code that you can change in the classroom during the class, and in which you can even put values suggested by your students. So this is all I would like to show you today. And if you think the result was interesting and if it's going to help you, please click the like button, let a comment, subscribe to our channel. Thank you for watching.